Okay. Namaste one and all. Now let's see understand. This is nothing but a third part in the experiment 8. That is nothing but an integrator. Okay. Now let's see understand the designing part of integrator. Okay. Integrator, design an integrator for the following specifications. That is nothing but F is equal to 1 kilohertz, C equal to 0.001 microfarad. Okay, we know the equation V naught is equal to -1 divided by RC, integration from 0 to T, Vi dt. Okay, we know the equation, this equation, how to find this equation, we need to apply some mathematical formulas or mathematical way. We need to find out this equation. Okay, I'm not going to concentrate that equation, how to get this equation. We don't need this equation. Okay, we should know this equation. Okay, how to find this equation, how this equation will going to come. It's very not complicated derivation. It's a very simple derivation. Okay, let me discuss in the future, but we need to consider here only the frequency formula. F is equal to 1 by 2 pi RC. Okay, that much is enough for this experiment. Okay, now we have F is equal to 1 by 2 pi. That pi value is 3.142 into RC. Here they mention F and C. We need to find out R value. Okay, R is nothing but 1 divided by 2 pi, 1 kilo into 0.001 microfarad is nothing but 15.9 will going to come. I'm going to consider 15 kilo ohm only because of the I'm not going to consider in practically descriptive experiment. We're not going to get 15.9 kilo ohm. So the next value is 15 only. So that's why I'm going to consider 15. Here in the MULTISIM platform, you can consider 15.9 also. Okay. Now F is equal to 1 kilohertz, C equal to 0.01 microfarad, R is equal to 15 kilo ohm. You need to distribute, you need to substitute in the circuit diagram only, here. Okay. Here everything is remaining same as an inverting amplifier, everything is remaining same, but here in the feedback, instead of feedback resistance, I'm going to connect feedback capacitance. Okay, this capacitance will going to play very important role. Okay, so that's why here the integration formula will going to come. Okay, so that's why this capacitor will going to play very important role in order to get the integrated output, because the main agenda of this circuit is whenever we are going to give the sine wave, it should give the cosine waveform. So like this is nothing but input blue waveform. The red waveform is blue waveform is sine wave. This is nothing but a cosine wave. That is nothing but a red waveform. Okay. Another one is whenever we give a square waveform, it should give triangular waveform like this. Okay. Square wave is nothing but a input. Square waveform is triangular waveform is nothing but a output. Okay. Okay. How this circuit will going to play in the simulate? How we should simulate in the MULTISIM platform? Let's understand. Okay, very simple. All the components are I'm already placed it. Okay, I'm applied grid. Okay, here the difference, compared to inverting amplifier, here this difference is C, that is nothing but 0.001. Instead of RF, I'm going to use CF. Okay, now I'm going to run. Before I need to set 1 kilohertz and then 2 volts peak to peak. 2 volts means here we need to set 1 volts peak. Okay, now I'm going to run. Yes, this is the expected. Because here I'm going to consider square waveform. So output is rectangular. Sorry, triangular. Okay. You may observe here. Input is positive. Output will going to be negative. From output will going to change from positive to negative. You can observe here. Output is negative. Input is negative. Whenever input is negative, output will going to change from negative to positive. Right. Whenever input is positive, output is going to fall, rise, fall. Okay, because why? Here in the formula we are going to observe negative sign here, negative sign. So that's why it is going to act as an inverting, like 180-degree phase shift. Okay, yes. Now I'm going to change this one to sine waveform and then run. Okay, yes, we are going to get cosine waveform. Like sine waveform will going to start from here, from 0. It will going to start from here. So that's why input sine, output will going to be cosine. Okay, yes. Thank you so much. It is nothing but a integrator. Okay, integrator. In the future videos, in the next video, let's understand differentiator. Okay.